Hello and welcome to the second lecture in this bivariate analysis, that is chapter number 10 of our comprehensive course on artificial intelligence, machine learning and data science. Now, in bivariate analysis, we created one simple data frame with only two variables, x and y, and we plotted some scatter plot and correlation matrix and heat plot and all that. But that was just two variables, x and y. Now we want to do more like industry like case where multiple variables are there, and we will use the example of that only, that is our cleaned employee details.csv. That file we have saved in previous lecture. So let me execute it and run that. So it has no nulls, no duplicate rows, and it has no outliers. So reasonably clean file. I'm clearing the output because I need the vertical space. Now I decide some base directory. These also we had done in earlier chapter, that we want to store all the plots which we are going to generate over next few cells in and in one particular directory, rather than displaying them in the Jupyter notebook, because they will occupy so much space. Then I will have to scroll down a lot. Okay, so rather than displaying them in the Jupyter notebook, we are storing them in one directory. So we are taking OS module, and therefore we imported that here. Import OS. It is a built-in module provided with Python. So os.path.join os.get current directory. So get current directory will take me to this current directory, that is C users ecube. C users ecube basic ds py 311. Okay, and here I can see that chapter 10 and chapter 9 and all chapters are there. So here a new directory will be created. So this is my current working directory, C users ecube basic ds py 311, with which this new directory will be created. So path will be joined. Joined means a slash will be added, and employee details bivariate. So at present there is no such folder. Whenever it is required, we will write the code that way that it will be created. Now then os.make directory base directory. So now this base directory which we have saved in this variable, that will be created by this command make directories. And exist OK equals true. That means how many times I am going to run this cell, I don't know. So it is possible that the directory may already existing. Then also, if it is already existing, then overwrite it. That is what is the meaning of this. Okay. And inside that directory, whenever this folder is created, inside that I want three subfolders. One subfolder for scatter plot, one subfolder for correlation heat map, and one subfolder for pair plot. So that is the meaning. So let us create for subdirectory in the subdirectories. So I take each these one by one. os.make directory, os.path.join base directory, comma subdirectory. Base directory means this whole. So what this for loop will do, it will create first these employee details, comma bivariate. Okay, and inside it, when this first element is here, then it will create inside scatter plot. Then next iteration will start. It will take this as the subdirectory, and therefore inside this now the second subdirectory will be created. The next iteration will start, and so on. So it will pass through all the three elements of this list, whose name is subdirs, and one by one it takes subdir from that and creates a subdirectory. So let us run this, and maybe subdirectory should have been created by this time. No, base directory, sorry, is not defined. So I have to run this first, and then run this. Yes, now employee details bivariate. This, you can see that directory is created, and inside the three subdirectories which are named this way, they are also created. Fine. Now let us perform bivariate analysis. As always, whether univariate or whether bivariate, the first step is always this, that df.select_d types, and in d types, if you want to isolate categorical column, then write include equals object, and if you want to isolate numeric column, then write include equals int 64 and float 64. Depending upon your architecture, it is possible. If you are 32-bit computer, then int 32 and float 32. Okay, that might be possible. So then I write numerical column, then categorical columns separately. I may even add two cells just to check that what are the numerical columns and what are the categorical columns. Okay, and so the numerical columns are here, this and this are categorical columns. Now, as I earlier also said in previous chapter, this ID is not much significant, and similarly the date of birth or date of joining, they are also not much important. Okay, now start plotting scatter plot. We have already seen what is a scatter plot. For that earlier example, I have restarted my kernel, but let me quickly plot that earlier example. This type of plot of one variable versus another variable shown by each observation shown by a dot, this is called a scatter plot. Okay, if scatter plot shows linear variation, this is also a scatter plot, and if it shows linear variation, then you can try linear models for prediction. Otherwise, you can try non-linear models like SVM. This is pair plot. It shows the histogram of variable x univariate, and it also shows the graph of x versus y. This is x versus y. Similarly, this here shows the histogram of variable y, and here it shows the graph of y versus x. Okay, so that we know this kind of plots with many multiple dots, that is the scatter plot. Also, we had plotted correlation matrix and heat map. So this was our correlation matrix, and this was our heat map for only two variables x and y. Now we want to do the same thing for multiple variables of my this data frame, cleaned employee details.csv. If I open that, then you will see that it is this data frame, and it has several columns and 50 or so rows are there. Okay, fine. Now here I am writing subdirectories is equal to scatter plots, correlation heat map, and pair plot. Okay, these are the subdirectories, and I have created those subdirectories. So these are created here in where is that? Basic employee details Bi-Variate. Okay, inside these three directories are there. Fine. Now numeric and these columns I am isolating for my detailed data set, and I think I have to read this because it is still taking the. Okay, now these are the numeric columns and these are the categorical columns. This output I am clearing just to save the vertical space. Now this code for column in numeric columns, so it will one by one take these columns, employee ID, then employee salary, and so on. For column 1 in numeric column, so that means this say is the column 1, and then inside there is a nested loop for column 2 in numeric column. So it will take these as the first column, and one by one all others as the second column. So that means employee ID versus employee salary scatter plot will be plotted, then ID versus age scatter plot, then ID versus performance ranking scatter plot. So many scatter plots for ID. Then it will take the next employee salary, and it will plot salary versus ID, salary versus age, salary versus performance ranking, and all that. So if columns are not equal, so that means choose only two different columns and plot the graph. This much code is our standard way of plotting the graph. That decide first create a figure, empty figure of some fixed size, then decide which plot you want to plot. So I want to plot SNS.scatter plot. Then assign the data whose plot you want to plot. So I want to plot data is equal to ds, and first x is equal to column 1 and y is equal to column 2. So whatever two columns I am selecting in my for loop, those two, one versus another, that scatter plot I want. Then plt.title, so will be giving me title of scatter plot of column 1 versus column 2. Then plt.ylabel and plt.savefig. Savefig occurs in this directory, that is this scatter plot. So if I execute this, then my scatter plot should be populated. You can see there are several scatter plots created. Now ID scatter plot, though it is populated fine, ID versus age, and here I am keeping, but not much meaningful insight can be obtained. Then age versus performance. Now this is something which can give some insight. For example, you can start with hypothesis that young people perform very highly, but you will see that hypothesis is not much supported by this data distribution. For example, this is a 25-year-old person, but his performance ranking is only 6. This is our 30-year-old person, but their performance ranking is 10, only one or two. The others are having performance 7.5 or 7 or something like that. This is 35, so that means the performance ranking is 8 still. Then this is somebody who is above 40, and still these are in various different performance ranking. So it seems that more or less age has nothing much to do with performance ranking, and even highly aged person can rank very high in performance ranking also, and even very young person can rank very low in performance ranking also. And in other age groups, there are the distribution is having multiple points along different performance ranking. So it seems that I can make a hypothesis from this that age is not related with the performance of the employee. Okay, now this is age versus salary. Now for that, normal hypothesis can be that as the person becomes a senior, age increases, salary increases. Now here some rough that kind of pattern is seen, but very rough. Again, the points are scattered, but a trend is at least visible that some this kind of trend is there. So at very low age, the low salary band is more prevalent. In the median age, the salary actually reaches a peak, and after somewhere 35 to 40, the salary actually starts decreasing. Okay, except this person whose performance was also at highest, and maybe his salary is also at highest. Now whether he's an outlier or maybe he is the owner and CEO of the company, so he has no choice of then performing the best. And of course, then for his hard work, he is the owner, so he will grab the maximum amount of salary too, right? Now this scatter employee ID versus age. Again, that is not much, because age versus ID plot we have seen. This is ID versus age plot. So not much significance. ID is just an ID. Okay. Then ID versus performance. Again, not much significance. You can see there is not much pattern in that. Okay. Then ID versus salary. Again, not much significance. No clear pattern emerging here. Performance ranking versus employee age. Now that you can see, that was here seen age versus performance ranking. So here ranking versus age is there, and you can see that again there is, it is that hypothesis that low ranking means young person and high ranking means old person is not much correct. In fact, majority of the rankings are in median region and the majority of the age are also in median region, except these and these two fellows, which can be considered as sort of outliers. Now, if you keep age versus performance, then there is no need of keeping performance versus age. Okay. So what I can do is I can delete this. Similarly, all the plots which were having IDs, they also I am deleting. So ID, because ID is not much significant thing. So ID, then here performance, ranking and age I am keeping. Age and salary I am keeping ID. So delete this. Then ID, so delete that. And this is also ID. So delete that. Now what are left are age, employee performance and age, salary. So performance ranking versus employee ID, again ID. So delete that also. You can see that large number of plots were plotted because you used the for loop, ranking and salary. Now that is also one helpful plot. The reason is that it shows a kind of mirror to your or organization itself, that is your organization really rewarding the highly high performant employee by higher salary. Then you can see that seems like yes, here some trend is visible, like this kind of trend, that you can see that the one who had highest performance ranking, his salary also is highest. These two are also having 10 performance ranking, and this fellow somehow has very little salary, so something must be done for this person. But this person is getting decent salary. These two have nearly these three have 9 rates the ranking performance wise, and again you can see that you are paying this fellow little bit less, but other two are getting decent salary. So this type of plot is having a lot of insight, because you can find out those employees which are good performers, like here 8, 9 and 10 level performance out of 10. These employees good performance but paid less, then maybe they are the case for giving a salary hike. On the other hand, there may be people who are less performer, these two. So then you can, but you are paying them 50,000 nearly, and this also 5 is not considered a good performance in corporates. So you are paying them 60,000. These two also 50,000. These three guys. So you may call these 2 and these 5, 6 people and warn them that either improve your performance, enroll yourself in performance improvement plan, and then you then you otherwise be ready for a salary cut. Okay, so this is how you can keep your salary budget relatively constant, but at the same time your highly working high performance employee will not think to leave your organization because of low salary. Because if you detect this thing that high performance employees, these two are being paid less, you will immediately increase their salary and proportionately decrease their salary here. So that is how this is a useful insight. Then salary versus age. Now age versus salary is already there, so salary versus age is now not much useful. Then salary versus ID. ID is not useful, so delete it. And salary versus performance. Again, performance versus salary is there. That is this. So this is also not required. So hardly, ultimately, 3 scatter plots were important. I think we have not yet plotted others. So let us proceed further with our code. Now correlation heat map. So how to plot first correlation matrix, that we know that you can just write df. Now numeric columns dot code. Okay, numeric columns is required because correlation is a number, so you cannot find correlation between categorical column. Okay, so numeric columns dot code, and once that is found, I can take this in the next next line here, and then I can even show the output. You can see that these are the correlations between various pairs of features. Okay, so these are the correlations between individual columns, ID and ID1, salary and salary1, this age and age1, and rank performance ranking and performance ranking 1. So of diagonal elements, sorry, diagonal elements, they are always having 1 because they are correlation of a column with itself. Other are important. Say this is negative correlation, so ID is having negative correlation with salary. So as ID increases, salary decreases, somewhat like this. Of course, ID is not that significant, but just as an example of what does negative means. Then salary with age. Now that is a reasonably strong positive correlation. So that means as age increases, salary also increases. And salary with performance, that is also moderate positive correlation. So as performance improves, salary also improves. But it is not as strong as it should be for your organization's benefit. Then age and performance. So there you can see that it is having weak positive correlation. So that means as age increases, performance improves. That is true. But improvement is very gradual. Okay, so that is what you can see. Rest of the are already included. For example, this 0.446 is here salary and performance. Here performance and salary, so they are already included. This is age and performance. This is performance and age, so included. Fine. Now you can plot a heat map. Annotation is equal to true. This is the color palette which you want to use, and you want to round off this each correlation up to 2 digits after the decimal point. So if you plot the heat map, you get somewhat like this, and it is saved in the heat map folder. So that is box plots are there here. Okay, these box plots are thing are coming later on. So let me delete. It is from earlier iteration. So delete. Okay, they are not empty. So I will have to go and delete from here. C users eCube basic DS Pi 311, in which folder is the employee details Bi-Variate and all these box plots. Okay, so I am deleting them, and correlation heat map is there, so that is here obtained. This is my heat map that shows the same whatever details were shown by correlation matrix, but they are the details are better than just a simple table like this. So now I can plot correlation heat map, and this is the heat map. Okay, fine. Now let us move further. Pair plot for numeric column. Heat map and correlation matrix are also for numeric column, and pair plot is also for numeric column. So if you draw pair plot, we have already seen what is a pair plot. So now let us see the pair plot for this. Then it comes out to be like this. This is ID versus ID, ID and ID. So histogram is there, but normally earlier we got histogram. Let me clear this output. Earlier we got histogram this, but this time in the code I have written kind is equal to KDE plot. So if you write kind equal to KDE while plotting the pair plot, then that kind equals KDE, then you will get this kind of pair plot. Okay, so instead of histogram you are getting kernel density estimation. Now this is salary versus ID, not much important. This is salary versus salary, so univariate distribution. This is age versus age distribution, and this is performance versus performance. So reasonably good normal distributions are there. This is the scatter plot of age versus salary, and this is the scatter plot of age versus ID, not important. Performance versus the salary, this one that is important, and age versus the performance, or performance versus age, these are important. So these three, that is sorry, your screen was occupied. I'm really sorry for that. Okay, let me quickly. This is ID versus ID. This is salary versus salary. This is age versus age, and this is the performance versus performance. So these are univariate box plots. And instead of histogram, we have chosen kind equals to KDE. So it gives a smooth plot, more or less bell curves. Among the scatter plot, any plot which involves ID are not important. So these three are not important, and these three are only important. That is this one, age versus salary. This one, performance versus salary, and this one, performance versus age. Okay, so these three scatter plots and these four KDE plots, that much is important from the pair plot. Let us move ahead, and this time I take one categorical and one numerical variable, because there are only two types of variable in data frame, numerical and categorical. So how many pairs you can make? The numerical with numerical, numerical with categorical. That will also include the reverse categorical with numerical, because they are same. And then third is categorical with categorical. So either two same types, n with n or c with c, or two different types, n with c. Three types. So now this is categorical versus numerical. So we take one column in categorical columns, and I am taking this down so that you can actually see it. What are categorical columns? Okay, and what are numerical columns? So numeric I have brought down. Now categorical also I am bringing down. So these are categorical columns. Now for categorical columns in cat columns, and for numerical in num columns, so take first categorical column, that is outer for loop, and iterate over this all one by one. So this with this. So one categorical, one numerical pair, then first categorical only, but second numerical, first categorical, third numerical, first categorical, fourth numerical. Now all numericals are used up once for this first categorical. So move to second categorical, this categorical and this numerical, then this same categorical but second numerical, then same categorical, third numerical. So that is the meaning of these two for loops. Rest of the code is simple. First decide figure size, that is plt dot figure, and in that you write fixed size is equal to a tuple of width and height. Then plt dot plot, which you can write sns dot plot also, sns dot box plot, and of what? One categorical, so df cat, and another numerical, df num. They are x and y. Okay, PLT dot title is box plot of categorical column versus numerical column. PLT dot X label is categorical column and PLT dot Y label is numeric column. And the save the box plot in this base directory plus box plot of cat versus num dot join that directory. So here multiple that kind of directories will be created. And if I keep it that way and plot it, then here directories will be created. You can see multiple box plot directories are created. These are earlier already there, correlation, pair plot and scatter plot, but these are newly created. And multiple are created because there are 1, 2, 3, 4 and 5 categorical, and there are 1, 2, 3 and 4 numerical. So 5 4s are 20 will be created. But I don't want all, that is clear. I want all date kind of thing are not that important. Date of joining and date of birth, they are not important. And all ID kind of thing are also not important. So I can go to that my folder and all these box plots are there, among which date, 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 date. So this I am deleting, and ID. So ID. Okay, I think that's it, right? Uh, Let me delete. Okay, now even this among this there are same pairs in reverse order. Department versus age. Then there will be somewhere age versus department if it is possible. Then you can delete that. Okay, department versus performance ranking. Department versus salary. Marital status versus age. Then marital status versus performance, marital status versus performance, qualification age, qualification performance, qualification salary. Okay, I'll have to keep all this and I will show you this. So first, this is department versus age. So this shows my which department is aging. So sales department seems to be nearing median age is 40. So it is the oldest average age, and it has maximum variation of age also. Variance is also high. And which department is youngest? Then HR department is youngest, around 32 years. Okay, so that is one this box plot is showing. Okay, this correlation and heat map we have already shown. Now the second is department versus ranking. So which department is performing well? So that I can see here that HR department is performing really well, 8 median performance rank, and which is performing the worst. So then perhaps these two, not worst, but at least you can say average performance, IT and sales department, and even this also finance department. Okay, so then department versus salary. Okay, so let us see who is taking major chunk of my salary. More or less medians are here. So that means 50,000 slightly less or more. That are the median salary. Okay, 45 to 55. This department, marketing department, is paid the minimum, only 40,000 median. But maybe I think for each successful sale, we usually the tradition is to pay them less salary but some commission. And also in both salary there are outliers. These two are paid very less in finance department. This one person is paid very less in IT department. This is paid very high in marketing, and these two are also paid relatively higher in marketing department. Okay, so that is about this thing. Now department versus salary, then marital status versus age. Now as such, this is not much important social science point of view, but not from business point of view. But it shows some strange kind of thing that married people have 32 years age, widowed a median age is 35. So mortality is pretty high in this particular department. Maybe it is not mortality, but wife's mortality is very high. Single median age is 40, and divorce median age is also around less than 35. So people are getting fed up with that married life also very quickly in this department. Okay, but this seems to be a slightly unrealistic picture, but it is there. And the basic tenet of data science is never to mess with whatever data says. Okay, then this thing. Marital status versus performance ranking. Yes, that is also important. So it may give some insight. It says that median performance of married people is around 7, widowed people is somewhere around 6, single people is also around 7, and divorced people is around 7 only. So as far as the marital status and performance is concerned, you can say there is nothing much to choose between the 4 groups, except widowed people are performing a bit poor. Okay, then here, for example, marital status and salary. Or before that, I think marital status and performance that we have seen, no? Marital status and salary. Now that is not much important thing, but you can see that your organization is paying married people around this much salary, widowed people whose performance was found wanting, they are getting more median salary, which is interesting. Single people are getting the highest salary, and divorced people are getting again the median salary of around 55,000. Okay, so this seems to be some anomaly here, slight. And this is bigger anomaly because widowed their performance was less, but their median salary seems to be high. Okay, then now here qualification and age. So if you open that, it shows that there is that hypothesis. If you take that highly qualified people will be with gray hair, then actually it is wrong. PhD people, their median age is only around 32. Okay, while high school people, their median age is 37, and bachelors, their median age is 35, and master, their median age is also 35. Okay, now this thing, this is okay. This is employee qualification versus performance ranking. So seems that performance-wise, PhD and high school both are at same level. Median performance is nearly 7, while bachelor have slightly, they also have 7, and 6 is the performance of masters. So these three groups have nearly equal performance, but masters have slightly poor performance. Then this qualification and salary. Now there you are seeing an interesting thing that you are paying less to PhD, even though they were highly qualified. They are highly qualified and their performance was also good. You are paying less. High school you are paying slightly more median salary, and bachelor you are paying the highest. Master you are paying less, which is okay, but you are not paying as less as their performance was found to be wanting. Okay, so that is the situation. Pair plot and scatter plot we have discussed. So what else is left now? Nothing. Okay, all plots are saved. So this is how we save the plots and then use whatever plots among those are required for creating the final dashboard or the final report for the business owner. That is this visualization which you are doing from EDA that goes here, dashboard, report, etc. You are understanding now some of the arrows what are plotted in this diagram, right? Okay. Now about this thing, that what is the importance and detailed discussion on bivariate analysis. I did not discuss that. First, I straight away went to the code and we discussed the code itself and various plots and etc. But now you can easily study this thing on your own itself, and you will find that everything has been explained only. But few words you will not understand, so don't worry about that. For example, say this you will understand that in bivariate what type of analysis will be there. Then numerical to numerical, categorical to categorical, and numerical to categorical. Fine. What type of plots are plotted? Scatter plot, correlation analysis, pair plot, box plot. You have seen this. You have not seen grouped bar chart. So we'll see in advanced plotting that kind of chapter is there. Cross tabulation we have not seen. There is a statistical kind of analysis. So we are going to take separate chapters on statistics. This is 19th basic statistics. This is where is 21 and 22. I think by mistake I have closed them. But 21 advanced statistics and 22. Okay, still there should be one practical statistics. Okay, so basic statistics, practical statistics, and advanced statistics. These are the chapters where we will discuss about this cross tab and chi-square test and everything. So that few words, if you don't understand at present, then don't worry, they are going to come in later chapter. So I'm just telling which are those new words: cross tab, then stacked bar chart, mosaic plots. This we will see in advanced visualization. Okay, then this chi-square test, then ANOVA test and t-test. This will come in those chapters, 3 chapters on statistics. Outlier and anomaly we have already done. What is the strength of bivariate analysis? What it helps, that you will easily understand, and what are the practical application. Okay, so in different branches, for example, if you want to become business analyst or healthcare analyst or HR human resource analyst, then these are the various mm, applications. Now, what is the outcome of bivariate analysis? What do you get after all this exercise? You get some feature selection. That means it is possible that out of maybe 50 independent variables are there, 50 columns are there, you can choose only 10 most important or 15 most important columns. You can get some actionable insights. As you see those box plot and scatter plots and all that, you start getting insights that these two are linearly variable. As you see the correlation plot, that is heat map, you start getting insight that these are highly correlated. So you can keep only one of them and delete the other variable, okay, other column. Then improved prediction, because once you understand how the variable depends on each other, you can design better features and you can delete few columns, you can add few columns, you can add columns made by multiplication division. For example, height and weight are there. Now for human beings, the height and weight are highly correlated. So correlation will be, if it is real data, around more than 85%. So then you can combine those two into one variable, that is for example BMI, height divided by weight square. Okay, similarly if it is a cardiology related data set, then there are two variables, that the waist diameter and the hip diameter of the person. But if cardiologists have found, multiple research have said that they are individually not much important. So a person may be quite fat, waist diameter is more, but it alone does not give idea about the risk of heart attack. And similarly, hip diameter. But the ratio is very important. So if that ratio is falling within a particular range, then that person is highly likely to develop cardiac arrest. Okay. So you can design waist to height ratio, and that way you can get some this kind of variables. So bivariate analysis is essentially a step in understanding interaction between variables, and so that we can do more data driven decisions. So read this. Now you will follow most of things except some things which I have already told you, which will be covered in subsequent chapters. This has become long chapter, but please, bivariate and univariate analysis both are very important. This is end of the chapter 10, but here exercise is given, and you can again see that, not here, sorry, but at the end, yeah, here. Okay, so before exercise, I have given this sample data set how to create. So every student will create same data set, and their results will be comparable. Okay, and these are the exercise questions. Fine. So please do this. You will get the solution, but after some time. Thank you.